Hey, this is Donovan with South Geek here. Amazon announced their new Kindle this morning called the Kindle Fire. It is a 7-inch multi-touch tablet with a 1024 by 600 resolution, weighs in at 14.6 ounces, has 8 gigs of internal storage because most of everything that you're going to store on the unit is going to be stored in the cloud. Battery life gives you 8 hours of continuous reading, 7.5 hours of video playback with the wireless turned off. Has a USB port, stereo headphone jacks, and top-mounted speakers. Does not have a camera, does not have a microphone. The design is based on RIM's ill-fated Playbook tablet. Let's hope Amazon does better with this design than they did.
I give you guys all the view.
Can you move your hand out?
Yep.
Can you see the back? The back of the device?
You can. Just a second, I'm going to make sure everybody gets a shot. Moving to the back. Wipe. $415 grams. Very thin and light. Portable, so you can take it with you anywhere.
Are there any ports?
There is a power port as well as a headphone port. All the other buttons on the display, we
Can we see
take
the
it
back
off.
port real quick? Did he announce how much memory?
This is the port right here.
How
We
much
did not, but
internal?
I'm happy to tell you, 512 megs of RAM, 8 gigs of local storage, but note that we store all of your content for you up in the Amazon cloud, so you've got virtually unlimited storage.
So 512 RAM and 8 gig local storage.
That is correct.
Did they say what?
Browsers have built more or less the same way for the last 15 to 20 years, without a whole lot of new architectural approaches. And so we stopped and stepped back and took a fundamentally different look at a web browser of how you would build a web browser in the era of cloud computing.
If you look at a typical browser today, it's based on the original browser designs from the mid '90s, back when the web was much simpler. We didn't have mobile devices. We didn't have large amount of content to the extent that we do today.
We were starting to look at kind of like the difference in between mobile devices and the desktop experience, and we noticed that there was just a very big gap between just the performance of loading a page. So what do customers really care about? It's the time it takes to get something that's usable on the screen. And so we really wanted to kind of remove those limitations by taking advantage of AWS services.
So when you think about different types of computers and different types of ways of accessing the internet, each form factor is meant for sort of specific capabilities, right? There's massive desktop, computers that are meant for really heavy-duty graphics processing, for example. But as you kind of go down the chain to like more and more accessible form factors like a tablet, it's just not meant to do that sort of stuff. It's not meant to process and crunch a lot of heavy data, right? But when you add the capabilities of our cloud, where you've got EC2 instances with 68 gigs of RAM and 8 cores, and they're sitting right there on this massive optical network, they can take that work off. You still get the great form factor and the experience of the Kindle Fire, but you've got this huge amount of power behind it.
The biggest differentiator in our browser is the fact that it's split between what runs on your device and what runs in the cloud.
You can think of your web browser as a small store for some of the commonly accessed files that you use to browse the web. What we've done is extend that using the Amazon Computing Cloud to create a virtually limitless cache that can store the common files such as images, JavaScript, and cascading style sheets that are used to render the web pages you view every day. Because we've built this cache on top of the Amazon utility computing systems, it doesn't take a single byte of storage on the actual device itself, and that provides a much better user experience.
We can optimize what we're sending back to the device to account for screen size, pixel depth. So there's no point in giving you a 3 megabyte JPEG if it's going to look the same when it's 50K. And so we'll make that image 50K, and it'll get to your browser a lot faster.
Because of the fact that Amazon was sort of the pioneer in cloud computing, that gave us a different perspective. It wasn't just about an application that sits on a device somewhere. It was about, let's build a whole new system. Let's build this split browser architecture that leverages this great strength we've got with our AWS cloud to kind of change the whole game and really rethink how do you do web browsers?
I'm sure you've had the experience where you've been trying to load a page and the browser's just sitting there hanging, and you're like, I wish I were on a better network. You know, we're on a better network. Our back end has some of the fattest pipes to the internet that you'll find. And we do all the heavy lifting on the back end and then serve optimized content over this dedicated channel back to your device, so you don't have to worry about it.
There's a lot of great innovations that we're really excited about with this new browser, and especially around the split browser architecture, all the stuff that enables with, image compression or predictive rendering, machine learning, all the great stuff we can do, optimizing the last mile connection between the device and our cloud. The great thing, in my opinion, is you don't have to think about any of that. It'll seem like a traditional browser, just a lot better and a lot faster than you're used to working with.